Hey everybody, today we're going to start right where we left off here. We are going to work on part 2 of the probability 3 worksheet. And so we have two other types of scenarios that we are going to work with. We are going to talk about picking out socks in the middle of the night, and then we are going to talk about a deck of cards. Now we use decks of cards a whole lot in probability conversations. And a lot of people maybe didn't play cards growing up. Maybe they don't know much about them. So we will take a minute and we'll talk about how a deck of cards looks and so what that means to you. So let's start with the sock questions and then we'll just go from there. All right. What is the probability that out of the 20 socks in your drawer, you are going to grab 2 white socks? Now we are assuming they all feel the same. We are assuming it's just the middle of the night and you're just grabbing 2 socks. At this point, some of you might not even be wearing matching socks anymore. I don't know, but we'll do the probability anyway. All right, so what is the probability that you will draw 2 white socks out of the drawer? Okay, so there are 20 socks in the drawer, and 6 of them are white. Now, that means the probability of you drawing a white sock is 6 out of 20. But what if you drew a second sock? Remember, you're drawing 2. Well, if you think about that second drawing, now there are 19 socks in the drawer. And assuming you already picked out a white one first, now there are only 5 left. All right, so you work that out. 6 times 5 is 30. 20 times 19 is 380. Now this reduces really easy because you just take off the zeros and you just get 3 out of 38. Now, it did say in the directions, like I said before, do 3 out of 38 as a percent and a fraction. So we should probably do that too. And if you do 3 out of 38, you get approximately 7.9%. So not very good chances. All right, now I want to put something out there. Just a little side note. This is about the time where people look and they're like, well, why did we bother learning permutations and combinations in a probability chapter if all we're going to do is just draw blanks and multiply anyway? I want to show you another way to do this problem that will give you the exact same answer. Okay. Now, if you're picking 2 socks, so again, this is another way to do problem number 21. If you're picking 2 socks out of the drawer, the order does not matter in how you pick them. You just want 2 white ones. So there are 6, and you are choosing 2. Okay. Now, if you consider the whole drawer, there are 20, and you are choosing 2. Now, if you were to take a calculator and you were to do 6C2, you would get 15. And if you were to do 20C2, you would get 190. Guess what? 15 out of 190 is the same as 3 over 38. Okay, so I wanted to bring that up real quick because, you know, sometimes it just seems like what we're doing isn't related. But I'm just telling you right now, it all fits together if you just work through it. All right, let's go to number 24. 2 Red Devil socks. Now, I don't know if they even exist. Maybe the athletes have them as part of their game day gear. I'm not really sure. I'm just going to wing it. The problem exists, so we might as well go with it. So the probability of having 2 Red Devil socks. So there are 2 socks in the drawer out of 20 that have Red Devils on them. As soon as you've picked one of those socks, now there are 19 socks left. Only one of them has a Red Devil on it. So you end up getting 2 out of 380. Which would reduce to 1 out of 190. And then 1 divided by 190. That is less than 1/2 of 1%. All right, there you go. Those would be the 2 ways that you could write your answers for number 24. All right, now for number 25, 2 socks that are not white. So now you're talking about, well, there are 20 socks in the drawer. I don't want either one of them to be a white sock. 14 of them are not white. As soon as you have drawn one that is not white, now you have 19 socks left in the drawer. 13 of them are not white. Okay, so you multiply that together, you get 14 times 13, which is 182. Divided by 380. Now this one is not going to be a good one to reduce. There's only one way to do it, and it's divide by 2. You get 91 out of 190. So yeah, that did not reduce a whole heck of a lot. Now, if you want to do it as a percent, 91 divided by 190 is 47.9%. All right. Now, 2 socks that do not have Red Devils on them. Okay, so that means what you're going to have to do is think about all the different socks that do not have Red Devils on them. Out of the 20 socks in your drawer, 18 do not have Red Devils on them. Then as soon as you have chosen one of those socks, you now have 17 left out of 19. So we're going to have that 380 on the bottom again, which is pretty much what we've been doing. And if I remember right, this is 306. If I'm wrong, then that's not going to be good. So let's do 18 times 17. So 306 divided by 380. All right, now, so when you are looking at a problem like 27, 2 matching socks, remember there are a few different ways that it can match. They could both be white, they could both be blue, they could both be black, they could both have a Red Devil on them. So the only way you can actually get 27 right is if you know all of the probabilities for 21 through 24, okay? And then add them up. So the probability of getting 2 white socks is 3 out of 38. And so you figure out what that is. Then you add in the probability from 22, and then you add in the problem from 23, and then 24. So I just want to throw that out there. All right. When you get to 28, by the way, probability can't be more than 100%. So if you want to know the probability of 2 socks that don't match, you could just take the probability of 2 socks that match and then just take it away from 100. So you take 100% and then you take away number 27. Okay. So let's say that there was a 22% chance that you have 2 matching socks. Then that means your probability of them not matching would be 100% minus 22%. So anyway, just wanted to throw that out there. Let's get into the deck of cards. Okay. For the next questions, assume that you are using a standard deck of 52 cards. All right, you pick a card from a deck of cards, find the probability is red. Now, I'm putting this up here. This is from the website Card Player. They do talk about poker and things like that. I'm not trying to encourage any of that, but in probability, you are going to get problems that involve decks of cards. And so having all 52 in front of you is a really good way to see just what they're getting at. So find the probability that you will draw a red card. Now, if you're looking, there are 52 cards in a deck of cards. 26 of them are red. Maybe it's the Ace of Hearts. Maybe it's the 3 of Diamonds. I don't know. But 26 out of the 52 are red. So that one, maybe I shouldn't have even gone over with you because that was just way too easy. 26 out of 52, which, in case you haven't picked up on it, that's 1/2. That is 50%. All right. I don't want to do too many of these, so let's just do a couple more just to make sure you've got it. Find the probability that the card is a face card. Well, face cards have faces on them. I know that was just a very bold statement on my part. Now, let's see if it shows up with a face. There you go. Kings have faces. Queens have faces. Jacks have faces. Those are the only ones that technically have a face. Now, a lot of times, you know, if you're playing a game, sometimes a 10 will count for the same thing as a face card. But if we're just being technical, the ones that count as face cards are kings, queens, and jacks. And there are 4 of each. 4 kings, 4 queens, and 4 jacks. So the probability the card is a face card is going to be 12 out of 52. If you reduce it, you end up getting 3 out of 13. And then we could bring the calculator back in here, and 3 divided by 13 is 23.1%. All right. Last one in this section, I want to go over 8 or less. What is the probability that you will get an 8 or less? So that means if we go back to our odds calculator over here, an 8 or less means any of this on down, so that would be any of these, all the way down to a 2. Aces are considered higher. They're not considered lower in a lot of the games. I mean, they can be, but for the sake of this, we are going to assume that they don't count as lower cards. So we have 7 spades that count. We have 7 diamonds. We have 7 clubs. We have 7 hearts. That means there are 28 cards that are considered 8 or less. So 28 out of 52. That would reduce to 7 over 13. And we swing the calculator back around. That's 53.8%. All right, so we got this, we got this. All right, now we're talking about two-card hands, and that's going to be more like what you see in a lot of these games. You know, maybe you're sitting around playing cards with your family, that sort of thing. Let's see, what is the probability that you are holding two cards that are black? So according to this, there are, out of the 52 cards in the deck, 26 of them are black. Now, as soon as you have chosen a card, now you have 51 left, 25 of them are black. Now, again, I brought this up earlier. If you were really, really good at combinations back in the day when we were practicing them, that was actually just lesson 2. I say back in the day, but it's really not that hard. That's basically what's going on here. There are 26 black ones, you're choosing 2, and there are 52 total cards, and you are choosing 2. Now, a lot of people tend to do better when it comes down to just laying it out and seeing it and using blanks. But I just wanted to show you how that would look. All right. Anyway, so we're going to throw this in the calculator. 26 times 25 is going to be 650. And then 52 times 51 is going to be 2,652. Now, what would be a good way to not ever have to deal with what just happened? I mean, because that looks really, really frightening. What is the best way to just never have to do that? It's not bad to write it down. I'm not trying to get you to erase your work. I'm just trying to show you here. What if, since we know 26 over 52 is just 1/2, what if next time we just did 1/2? Well, then you would get 25 times 1, which is 25, and then 51 times 2, which is 102. And by writing it that way, you don't have to reduce. You could just do 25 divided by 102. It doesn't reduce at all, so it's not that I'm encouraging you to not reduce. I'm saying in this case it doesn't. And you would end up getting 24.5%. All right. The last problem we're going to do together is going to be number 38. What is the probability that you are going to be dealt 2 cards and they are both jacks? Okay, so depending on the game that you're playing, getting dealt 2 jacks could be a really good thing. What is the probability that you will be dealt 2 cards and they are both jacks? Okay. So what is the probability? Well, let's take a look here. There are only 4 jacks in the deck out of 52. The entire deck, only 4 jacks. And as soon as you have chosen one, now you only have 3 jacks left out of 51. Okay. Now, if you want to save yourself from having to reduce later, then let's divide that first fraction by 4 on top and on bottom. And let's reduce that second fraction by 3 on top and on bottom. And then when you multiply all that together, you end up getting a 1 out of 221 chance. And then if you do 1 divided by 221, you throw that in on the calculator. You end up finding out, and this has happened a few times now, you get less than 1/2 of 1%. You have a 0 0.45% chance. So if you are playing a game and you're hoping that your two cards are a pair, the probability of you getting a pair of jacks is less than 1/2 of 1%. Now that'll be the probability for any pair, because they're the same number of cards in the deck, whether they're jacks or tens or nines or queens or whatever. So then the probability of getting any pair would just be all of those probabilities added together. So hopefully that helps you get started here. I just want to throw out real quick, number 40 is going to be the bonus problem of the day. It is a little bit crazy, and the probability is going to be very small, but I think you can probably handle it. So anyway, I hope this helps get you a jump start. Thanks for watching. Take care of yourself and each other.